Gold begins here, locked inside ordinary-looking rock deep underground in America. Mark this contact for sampling. Nevada's ancient geology concentrated microscopic gold across vast mineral deposits.
The vein continues through this section.
Exploration teams map hidden ore zones before any rock is removed.
Control point confirmed. Core samples reveal gold-bearing structures invisible within the surrounding stone.
Start the assay interval right here.
Geologists read layered rock like a detailed map of history.
42 degrees, dipping west. Controlled drilling prepares precise blast patterns while protecting valuable ore boundaries.
Hold there, alignment is centered. Every bench exposes fresh geology for careful mapping and sampling.
Continue sampling across that contact.
Most gold remains microscopic, scattered through dense sulfide-bearing mineral grains. The sulfide concentration increases along this edge. Quartz veins often mark pathways where mineral-rich fluids once traveled.
The alteration widens toward the east.
Oxidized ore displays rusty colors created by weathered iron minerals.
Fresh material starts beneath this coating.
This section carries the planned grade.
Fresh ore looks unremarkable, despite carrying economically valuable gold particles.
Hand lenses expose metallic textures that guide experienced field decisions.
Bag this section separately for analysis.
Sample tags preserve location data for every fragment collected underground.
Tag and bag numbers match exactly.
Moisture and dust reveal contrasting textures across newly broken ore. The wet surface makes this contact easier to follow. Veteran miners scale loose rock before extraction crews advance safely. Face is clear on the left side. Experienced drill operators align each hole using surveyed reference points. Centered on the survey point.
Confirm the sequence before we clear the heading.
Careful charging creates controlled fractures without wasting surrounding mineral resources. The blast loosens ore into manageable fragments for mechanical collection.
The break stayed inside the planned boundary.
Loaders gather broken ore while spotters maintain safe working clearance.
Bucket is clear. Continue your lift.
Each truck carries a documented load toward the next processing stage.
Truck 24 is cleared for the haul route.
At collection points, crews separate oversized waste from payable ore. Hold the feeder, oversized material on the left. Sample records keep every extracted load traceable from its source. Load 24 matches bench 12 records.
That block is outside the ore profile.
Primary sorting protects downstream equipment and improves refinery feed consistency. Experienced crews remove hazardous debris before ore enters transportation systems.
Foreign metal cleared, restart at low speed.
Roger that.
Moisture control reduces airborne dust during underground ore handling operations.
Moisture is holding inside the target range. Loaders place measured ore charges into reinforced underground haul trucks.
Load centered. Bring the bucket back slowly.
Onboard scales verify payload weight before each truck leaves underground.
Payload confirmed within the approved range.
Operators secure every load to prevent spillage along steep mine roads.
Cover locked. All sides remain below clearance.
Heavy haul trucks climb carefully from underground workings toward daylight.
Truck 24, continue to the surface transfer. Surface crews transfer ore into sealed containers for controlled transport. Container seal number matches the shipment record.
Documented shipments travel under security from mine to refining facility.
Maintaining approved speed and following the assigned route. Checkpoint inspections confirm seals, weights, and custody records remain accurate.
Weight and seal match the mine departure record.
The refinery receives mineral feed from multiple American mining regions.
Shipment group is approaching receiving gate 3.
Security teams verify drivers and shipment documents before facility entry. Identity and shipment documents are confirmed for entry. Arrival staging keeps incoming loads organized by source and grade.
Truck 24, proceed when the lane turns green.
Every shipment enters through controlled receiving bays designed for traceability. Position confirmed. Engage the trailer restraint. Certified scales measure gross and tare weights for accurate reconciliation. Gross weight matches the expected shipment tolerance. No evidence of tampering or material leakage.
Inspectors examine seals and containers before any material is unloaded.
Representative sampling determines moisture, grade, and processing suitability before acceptance. Composite sample is building evenly across the shipment. Accepted ore moves into secure bins for initial refinery preparation.
Shipment accepted and routed to preparation bin 7.
High-pressure sprays remove loose dirt before ore enters crushing systems. Pressure is stable. Keep the feed rate steady.
Water classifiers separate fine particles from larger mineral-bearing rock fragments.
Fines are separating cleanly from the coarse fraction.
Magnets capture stray steel that could damage downstream processing equipment.
Metal capture confirmed. Crusher protection remains active.
Optical sorting identifies contrasting rock before primary size reduction begins. Sensor response is clean across the entire belt width. Cleaned ore streams are blended to stabilize incoming refinery feed.
Surface moisture is within the blending specification.
Blending equalizes ore characteristics before powerful crushers begin their work. Maintain thin layers to keep the blend uniform.
Variable speed feeders deliver consistent tonnage into each preparation stage safely.
Increase feeder 2 by 3%. Controlled moisture keeps dust low and material flow predictable throughout. Dust remains below the action threshold.
Metal detectors protect crushers from hidden tools and broken hardware.
Foreign metal cleared. Verify the belt before restart. Feed bunker is stable and ready for continuous operation.
Primary crushers apply immense force to break the hardest ore. Power draw is steady under the current feed rate.
Apron feeders meter heavy rock steadily beneath the crusher system. Raise the feeder 2% and watch the load.
Massive jaws compress ore repeatedly until fragments become small enough.
Crushing gap remains even across the full rotation. Crushed material exits onto conveyors for controlled downstream transfer operations.
Product size looks consistent across the entire belt.
Dust collectors capture airborne particles around every crushing transfer point.
Airflow remains balanced across every crushing transfer point.
Cone crushers refine rock size using continuous compression and rotation.
Chamber loading is balanced and product size remains stable.
Vibrating screens separate correctly sized ore from oversized material efficiently. Screen motion is even from feed end to discharge. High-pressure grinding rolls fracture particles along natural mineral boundaries efficiently. Pressure remains stable across the full roll width. Surge bins stabilize mill feed during changing crusher conditions automatically.
Mill feed remains steady despite the crusher change.
Grinding circuits begin liberating microscopic gold from surrounding mineral structures.
Density is stable and grinding energy remains on target.
Hydrocyclones classify ground slurry by particle size and density differences. Cyclone 4 needs a minor pressure adjustment. Oversized particles return for additional grinding until liberation targets are reached.
Coarse fraction remains inside the expected return range.
Particle size meets the flotation feed requirement.
Fine slurry advances only after particle size meets processing requirements.
Thickeners concentrate valuable solids while recovering reusable process water efficiently.
Overflow clarity is stable for process water recovery. Conditioning tanks prepare mineral surfaces for selective flotation chemistry downstream.
Conditioning chemistry is stable across all tanks.
Carefully measured reagents help separate gold-bearing minerals from unwanted rock.
Collector dosage matches the current ore blend. Air bubbles carry selected mineral particles toward the froth surface. Bubble structure is uniform across the cell. Flotation cells create a concentrated stream rich in valuable sulfides.
Cell 6 is returning to its target depth.
Operators adjust airflow and chemistry to stabilize the flotation circuit.
Reduce Bank 2 airflow by 5%.
Confirmed.
Final cleaner stages increase concentrate grade before dewatering and roasting.
Final cleaner concentrate is ready for dewatering. Pressure filters remove moisture from concentrated gold-bearing mineral solids efficiently.
Filtrate is clear and pressure remains stable.
Cake release is complete across the press.
Filtered concentrate forms dense cakes ready for controlled thermal treatment.
Drying systems lower residual moisture before concentrate enters the roaster.
Outlet moisture has reached the roasting target. Roasting converts sulfides and expose gold locked within resistant minerals. Oxidation remains complete across every furnace zone.
Gas cleaning systems capture heat, dust, and sulfur compounds safely during roasting.
Gas treatment performance remains inside operating limits.
Calcine temperature is safe for wet processing.
Cooled calcine moves toward leaching after its mineral structure changes.
Grinding after roasting exposes additional gold surfaces for chemical recovery. Regrind size is approaching the leach target.
Leach tanks dissolve liberated gold into carefully controlled process solution.
Leach conditions remain stable across the first tank.
Activated carbon captures dissolved gold as slurry moves through adsorption tanks.
Carbon loading continues to rise through the circuit.
Loaded carbon carries concentrated gold toward the refinery recovery circuit.
Loaded carbon is cleared for the recovery circuit.
Hot elution solution strips concentrated gold from loaded activated carbon.
Elution concentration is increasing exactly as expected.
Electrowinning plates dissolved gold onto steel cathodes using controlled electrical current.
Outlet gold concentration continues falling through the cell bank. Workers harvest gold-rich cathode sludge under strict security and traceability controls.
Cathode identification and collection vessel numbers match. Drying removes moisture before captured metal enters the smelting furnace safely.
Product temperature remains below the approved limit.
Controlled smelting separates impurities and produces rough gold doré bars.
Metal temperature is stable. Maintain the controlled pour.
Cooling remains even across every mold position.
Inspectors monitor cooling patterns that influence each doré bar's integrity.
Slag inspection confirms valuable metal was recovered from furnace residues. This slag requires another recovery pass.
Surface cleaning reveals cracks, inclusions, and other visible casting defects. Mark that line for visual examination. Experienced inspectors examine every surface beneath bright, standardized lighting conditions.
The line is superficial and does not extend.
Certified scales and gauges confirm each bar's weight and dimensions.
Weight and dimensions match the approved casting range.
Permanent serial markings connect every bar with its processing history. Permanent serial matches the electronic production record.
X-ray fluorescents provide rapid preliminary composition results without damaging bars.
Preliminary composition agrees with the smelting batch estimate.
Ultrasonic inspection detects hidden voids beneath apparently solid metal surfaces.
No significant internal discontinuities appear in this scan.
Dual verification protects custody records during every secure refinery transfer. Bar count, serials, and seal all match. All physical inspections are complete. Release remains pending assay.
Only approved doré bars advance after all inspections are complete.
Technicians drill representative samples from several precisely documented bar locations.
First location complete, proceed to the opposite end.
Higher assay fusion separates precious metals from accurately weighed samples.
Sample, duplicate, and standard are ready for fusion.
Cupellation isolates a tiny precious metal bead for final measurement and analysis.
Cupellation cycle and reference positions are confirmed.
Instrumental analysis measures trace impurities and verifies gold concentration precisely. Gold concentration agrees with the duplicate analysis. Final assay certificates reconcile laboratory results with refinery production records.
Assay results and production records reconcile within tolerance.
Weight, serials, and seal remain fully reconciled. Certified doré bars enter purification to reach investment-grade gold standards. Chlorination removes silver and base metals from molten gold efficiently.
Impurity formation is progressing evenly across the molten bath.
Electrorefining produces exceptionally pure gold for demanding international markets worldwide. Current efficiency and solution chemistry remain inside specification.
Pure gold cathodes receive thorough washing before controlled melting begin.
Wash coverage is complete across both cathode faces.
Final melting homogenizes purity before gold enter precision casting lines.
Final melt chemistry is uniform and ready for casting.
Automated molds shape purified gold into standardized market-ready bars precisely.
Mold position and temperature are confirmed for casting.
Measured pours ensure every bar begins with consistent metal weight.
Final pour weight is inside the casting tolerance. Controlled cooling prevents distortion while preserving each bar's structural quality.
Temperature gradient remains uniform across every casting position.
Mechanical release systems remove cooled bars without damaging finished surfaces.
Release completed without edge damage or surface impact.
Precision trimming removes minor flash from newly cast gold bars.
Trim depth remains shallow and within specification.
Finished weight agrees with the recorded pour mass.
Automated weighing confirms each finished bar meets its assigned specification.
Surface finishing produces clean, consistent bars without excessive polishing operations.
Surface is clean without removing meaningful metal.
Permanent markings identify purity, weight, serial number, and production date.
All permanent markings match the certified electronic record.
Marking depth and serial recognition are fully accepted.
Tamper-evident sleeves protect finished gold bars during secure distribution worldwide.
Seal width and tamper pattern remain consistent.
Assay certificates document each bar's verified purity and fine weight.
Certificate and bar serial are correctly paired.
Secure labels connect packaging records with the Refinery traceability database.
Packaging code and production history are fully connected.
Date code, seals, and documentation are all accepted.
Date codes and inspection marks confirm final packaging completion accurately.
Protected cases organize sealed bars for secure warehouse handling operations.
Count and weight match the case manifest.
Robotic palletizing builds stable, documented loads for guarded storage areas.
Pallet count, weight, and seal records are complete.
Final protective cases receive tamper seals before entering secure warehouse storage. Both seal numbers match the approved case record.
Automated scanners reconcile every sealed case with its electronic manifest.
Manifest, seals, and measured weight reconcile without exception.
Pallet restraints prevent movement while preserving every package's traceable identity. Restraint force is balanced across all four corners.
Security inspectors verify seals, weights, and case counts before release. All seals, weights, and case counts are confirmed.
Finished pallets cross controlled doors into the refinery's guarded warehouse.
Storage location and pallet identity are fully matched. Place this shipment in export hold position 12.
Vault systems organize packaged gold by serial, owner, and destination.
Temperature and humidity remain stable throughout secure storage.
Environmental controls protect documentation, packaging, and security equipment.
Inventory robots verify pallet locations without opening sealed transport cases.
Physical location and electronic inventory are fully aligned.
Two-person audits compare physical holdings with encrypted warehouse records daily. The physical holding matches every encrypted inventory entry.
Secure segregation keeps different customers and destinations clearly organized inside.
Customer and destination segregation remain correctly maintained.
Backup power preserves surveillance, access control, and environmental protection systems. All surveillance and access systems stayed continuously online. Warehouse release begins only after shipping instructions pass final verification.
Destination, carrier, and release date are fully approved. Armored loading crews stage sealed pallets inside a protected dispatch bay. Vehicle, pallet, and destination records are correctly matched.
Independent inspectors reconcile truck identity, seals, weight, and route documents. Vehicle identity, empty weight, and route documents are confirmed. Reinforced restraints secure gold shipments against movement throughout the journey.
All anchors and restraint points are fully engaged.
Dispatch teams coordinate guarded departures using controlled schedules and routes. Departure window and receiving appointment are both confirmed. Continuous tracking confirms each armored vehicle remains on its approved route.
Convoy is en route and tracking normally.
Armored convoys deliver refined gold to approved financial and industrial customers.
Scheduled refinery shipment is cleared for inspection.
Seals, serials, and arrival weight match the shipment record. Receiving institutions verify seals and serials before accepting custody officially.
Final serial and ownership records are fully confirmed. Market-ready gold completes its journey from hidden ore to trusted value.